This is one of a series of videos produced by the Further Mathematics Support Programme for A-Level Maths Revision. In this video we're looking at the AQA Mechanics 3 specification, and this is question 7 from the June 2011 paper. The question is about two spheres that are colliding obliquely. We're told that B is at rest when it is hit by A, which is moving at an angle of 30 degrees to the line of centres at a speed u. After the collision, A moves off at an angle of alpha to the line of contact, the line of centres, and we're told that the coefficient of restitution between the spheres is 5/9. So in other words, the information as given in the two diagrams. Question simply says find the value of alpha, and then having done that, find in terms of m and u the magnitude of the impulse exerted on B during the collision. Well, just putting some information onto the second diagram after the collision, then the velocity of A after collision, let's call that VA. The contact is along the line of centres there, so B is going to move in that direction, so let's call that VB. So you can see that we've got three unknowns, VA, VB and alpha, so we need three equations, and those come from considering the momentum in two different directions. So perpendicular to the line of centres, then there's only A's momentum to consider, so we can use conservation of linear momentum for A, and that gives us that the mass 4m multiplied by the velocity in that direction, which is the sine component, so u sine 30 degrees, that will be equal to 4m and the velocity VA and sine alpha. We can rearrange that to give us that VA, if we use sine 30 degrees as a half, VA is equal to u divided by 2 sine alpha. So that gives us one equation to work with. If we look at conservation of momentum along the line of centres, then we've got the other component of u, so 4mu cosine 30 degrees. But then we've got the two momentum for A and B in that direction, so 4m VA cosine alpha, and then plus 3m and simply VB because it's moving along that in that direction. So that's the conservation momentum along the line of centres. The other equation, the third equation, comes from restitution. So the restitution equation talks about the speed of approach and the speed of separation. The speed of separation is, if we look at the restitution along the line of centres again, then we have that the speed of separation is VB minus the component of A, which is VA cosine alpha, and the speed of approach is the initial before collision speed of A in that direction, so that is u cosine 30 degrees, and that's equal to 5/9. Now just making VB subject of that equation, VB, so we need to multiply by u cos 30, root 3/2. So we get 5/9 multiplied by root 3/2 times u. That gives us 5 root 3/18 multiplied by u, and then we need to add on to that VA cosine alpha. There's the three equations then. So what we can now do is to substitute into the equation at the bottom this conservation momentum. So we're going to substitute VA into here and VB into here. We'll also need, of course, that second one has also got an expression for VA in it. So doing that substitution then, so if I label these, if I call these by different names, I call this equation here equation 1, and this equation here equation 2, and I'm substituting into equation 3. So substitute 1 and 2 into equation 3, we get the following. For mu cosine 30 degrees is equal to 4m, and then we've got u over 2 sine alpha multiplied by cosine alpha, and finally 3m, and now we've got VB, so that's 5 root 3 over 18u plus VA, which is u over 2 sine alpha multiplied by cosine alpha. Right, just cleared a little bit of space on the slide there. Now we can obviously cancel through by m first of all these have m in them, and also cosine 30 is equal to root 3 over 2. So if we do that, we end up with 2 root 3 u in the first expression, and then on the other side of the equation we've got 2u and cos alpha over sine alpha, so 2u cot alpha, multiplying out the bracket. First one is the 3 cancels the 18 to give you 6, so 5 root 3 over 6 times u, and finally we've got u multiplied by u over 2 cot alpha multiplied by the 3, so 3u over 2 multiplied by cot alpha. Well, we can now see, of course, that we can also cancel throughout by u, so that all disappears. We've got two parts which have got cot alpha in them, and that's what we're trying to get, is the value of alpha. So if we put those two together, we've got cot alpha, and we're multiplying that by 2 plus 3 over 2. And then putting on the other side of the equation, we've got 2 root 3 and then minus 5 over 6, sort of 5 over 6 times root 3. So a little bit of fraction work going on here. The cot alpha 2 plus 3 over 2, that's the same as 7 over 2, so this is 7 over 2 cot alpha. And then on the right hand side of the equation, we've got obviously multiplied by root 3, so we've got 2 minus 5 over 6. Well, 2 is 12 over 6, so 12 over 6 minus 5 over 6 is 7 over 6 multiplied by root 3. So we're finally getting to something that we can start to recognize. Therefore, cot alpha, if we multiply by 2 over 7, cot alpha is equal to root 3 over 3. And you may recognize that. If not, you can use the calculator. Cot alpha is root 3 over 3, then that means that alpha is equal to 60 degrees. Well, quite an involved question, that one. But remember, these are fairly standard. You know, there are only these things you can do: the conservation of linear momentum in the two directions, perpendicular and along the line of contact, and then your equation for restitution. Yeah, so those three equations are always going to be the method of solving this sort of type of question. And then the rest of it you have to sort of commit to just working through the algebra. Looking at the marking for it, then there was M1A1 for getting that first expression there, and M1A1 for getting the equations here, another A1, M1 for the restitution equation, and then an expression for VB. And then we had method marks and answer marks, method, and finally 2 A marks for getting the final expression for alpha. I think it was M1 and A1 for the substitution, and then a final A mark at the end for alpha equal to 60 degrees. So 10 marks there, so it wasn't never going to be a straightforward sort of question to answer. Well, in the second part of the question, we're asked to find the magnitude of the impulse exerted on B. Well, impulse is equal to the change in momentum, and the change in the momentum will be the mass 3m multiplied by the change in the velocity, which is simply the VB. It was stationary to start with. We've got an expression for VB, which we can substitute from the previous working, which was VA cosine alpha plus 5 root 3 over 18 times u. And finally then the velocity of A, that was equal to u over 2 sine alpha. So substituting that, we get 3m u over 2 sine alpha multiplied by cos alpha plus 5 root 3 over 18 u. Well, the cos alpha over sine alpha we know is cot, and we had that as being equal to root 3. So this is 3m, and then we've got root 3 over 2 times u plus 5 root 3 over 18 times u. Sorry, a slight slip there. Cot alpha, root 3 over 3, not just the root 3, so there's a root 3 over 3 multiply in there. Multiplying through by the 3, and then gathering these two together, that turns out to be equal to 4mu and then root 3 over 3. So there's our expression. How far you need to take that, I suppose you could stop at this point. That would be an expression for the magnitude in terms of m and u. However, the marking which is given does actually give a simplified value. Whether you would lose a mark or not is unclear from the mark scheme, but there are 2 method marks and then an A mark awarded for that part of the question. Well, that's the end of this particular video. You'll find others at www.furthermaths.org.uk.